Today I'm going to be doing physics, and the topic I'm going to do is measurement. Measurement is one of the most important topics in science. That's because without measurement, you cannot do anything in science. Science will not even exist without measurement. What is measurement? Measurement is a way of finding out how much there is in a particular sense. For example, if I want to find the space between 2 points, this space, the line space between them is called distance or length. If I want to find out how heavy a thing is, I'm talking about what now? Mass. If I want to find out the hotness or coldness of a body, I'm talking about what now? Temperature. If I want to talk about but all these are different what now? Different quantities. Do you understand? These are quantities. And then you should note that for measurement, one very important thing is the units. You have to know the unit for every quantity. What is a unit and what is the function of the unit? The units help us to identify quantity. For example, if I give you 40, if I give you 40 without writing anything, you cannot tell whether this is a mass I'm measuring, this value is for temperature, whether it's for length, whether it's for time. However, if I have to write 40 meters, you know I'm talking about what now? Distance or length, because of the unit, meters. If I are written 40 seconds, you know I'm talking about time. If I've written 40 degrees Celsius, or I've written 310, I said degrees Celsius, doing something else here. If I give you 40 degrees Celsius, which is equivalent to 310 Kelvin, you know it's what now? It's temperature. You got what I'm saying? So, in physics generally, we have different classifications for quantities for measurements as it were. What I mean is, for example, what I'm going to tell you about now, I'll be dealing with fundamental quantities and derived quantities. These are the ones I'm going to deal with for the class today. There are also units. There are also quantities like vector. We have vector quantities, and then we have what now? Scalar quantities. Vector quantities and scalar what now? Quantities. All these are also what now? Different quantities. But I'm going to focus on fundamental and derived quantities today, like I said earlier on. So what are fundamental quantities? Fundamental quantities are quantities that you cannot define based on other quantities. You don't get them by a simple combination of other quantities. They stand alone. They are by themselves. So a fundamental quantity cannot be defined based on other quantity and cannot be derived by combining other quantity. At this level, we're going to talk about 7 of them. 7 of them. So what is a derived quantity? Derived quantity, like the name is, the derived quantity is a quantity that is obtained by simple combination of other quantities. They depend on other quantities. They depend on the fundamental quantities. Are you with me? Let's see what we're going to do, right? Okay, like I said earlier on, fundamental quantities are independent of other quantities and cannot be defined by other quantities. They can also not be obtained by combination of other quantities. So let's see some of these fundamental quantities. I said I'll tell you about 7 of them. The 7 basic fundamental quantities. We're going to be talking about mass, length, time, temperature, electric current, amount of substance, luminous intensity. And the first 3 are the ones you need to take particular note of: M, L, and T. Mass, length, and time. You will be using them again and again and again. Mass, length, and time. If you ask me, I'll tell you that they are the most important of all of them. Alright? So what is the unit of mass? How do we identify mass? The unit of mass was supposed to be gram. But because gram is too small, it was generally agreed that the unit of mass should be what now? Kilogram. This is the spelling of gram, and this is the spelling of kilogram. Alright? It was supposed to be gram, but because gram was too small, it was agreed that it should be what now? Kilogram. The unit of length is meter. Meter. Or it's spelled, one is American, the other is what now? Is British English. Meter. Meter is the accepted unit for what now? For mass, for length, sorry. And that will be M. For time is seconds. Seconds. And seconds will be what now? Will be S. Right? It's S for time. For temperature is what now? Is Kelvin. 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 There are other units. Like for temperature now, we have other units like what now? Like degrees Celsius. We have degrees Celsius, degrees centigrade. But the fundamental unit is what now? Is Kelvin. Electric current. Electric current is ampere. The unit is ampere. The unit for amount of substance is the mole. The mole. And then the unit for luminous intensity is candela. Candela. I could write that what now? C. All these are what now? Fundamental quantities and their units. Very important that you take note of this. Alright? So I'm going to go to what now? So derive quantities. Okay?